In this video, we are asked to determine the derivative of arcsine this, right? Perfect. So guys, to derive the arcsine, we always need to use the formula for the derivative of arcsine, right? I'm going to write it down here at the bottom, which is f prime x is equals to basically the derivative of x. In this case, our x is this guy here, right? And then all over square root of 1 minus x squared, which is this guy again, right? This is your x in this case. Sharp. So which means, ladies and gentlemen, you are going to basically firstly derive this and also square it and then just substitute into the formula, right? Perfect. So I'm going to remove the formula now. We can start. So we're going to do the derivative of the inside, which is d, and then you have 3 to the power of 5 in bracket x plus 5 all to the power of 5, right? All over dx. All right? And then this is the rule basically when we're deriving exponential functions. Ne? The rule is you do the ln of the base. So the ln of the base is going to be ln 3 because your base is 3 in this case. And then you derive the exponent. So the derivative of the exponent, we're going to use chain rule. Ne? By chain rule, I have to take, let me just come back here. By chain rule, I have to take this and multiply that. So there's 1, right? So basically, there's a 1 here, and then I'm going to times by 5, so I get 5. So I'm going to have 5 in bracket 5x plus 5. And then I need to minus 1 from the exponent, so it's going to be to the power of 4. And then I also, because I'm doing chain rule, I need to multiply by the derivative of the inside. So the derivative of 5x is 5. It's 5, right? And we can see that the derivative of 5 is 0. So we have that. And then after deriving the exponent, we need to multiply by the same function. So our function is 3 to the power 5x plus 5 all to the power of 5. Right, so I'm going to repeat this. So you do the ln of the base, and then you take the exponent, you derive it, is going to give you this guy, and then you keep whatever you had originally. So it's a 3-step process to derive the limit of an exponential expression. So and then obviously to derive this, we have to use a chain rule. Right, perfect. So now we have the derivative of the inside. We need to square the inside, right? So I'm going to have, okay, let me just underline that. Now I'm going to say, okay, 3 to the power 5 x plus 5 all to the power of 5. And then I need to square this, right? Remember, squaring this basically is like multiplying whatever is there by that. Ne? Don't make a mistake. Many learners multiply this and that. This 2 is not aligned with that. It's aligned with the base. It just means everything here is repeated twice. So basically the base times 2. Do you see it? Sharp. So the exponent here is 1. So 1 times 2 is going to be 2. So we have 3 squared basically because of the 2 that is there. So it's like we have 9 now. Because this 2, I cannot multiply it in here because I have an exponent there. So it's 3 squared, which is 9. So I'm basically having 9, and then I have 5x plus 5 all to the power of 5. Right. So now I have the derivative. I also have the squared. So I can now substitute into the formula. Right. So let me just select this to save time. So we're going to need this from here up until here. That is basically our numerator of the function, right? So let's see, what was our function? Our function is f of x. So the derivative of f of x is going to be equals to, okay, let's paste that here. paste. So let's move it here, sharp. So that is our numerator all over, and then we're going to have, okay, square root of 1 minus the x squared, which was 9 in bracket 5x plus 5 all to the power of 5. And this is the derivative, ladies and gentlemen. Aluta continua. Tango. Salute. Thank you for watching.